Okay, so today we're going to talk about inverse sine functions and cosine functions and inverse tangent functions. Now, in order, if you remember back to inverse functions, in order for, well, first of all, in order for something to be a function, it has to pass the vertical line test. So the problem is that if you were to take a sine function and invert it, so a sine function looks like this, and it definitely passes the vertical line test. But if you were to take the sine function and invert it, it would look something like that, which does not pass the vertical line test. So the inverse of a sine function or a tangent function, or tangent's a little weird, but inverse of sine and cosine, you cannot do an inverse of the entire function. It doesn't work that way. So, so in order for us to find values, we need to be able to look very carefully at where things are. Now, technically, you can find values outside of these ranges, but those are calculator problems, and it's complicated about why those work. So we're going to focus our efforts today on values that we can find without a calculator. Now, in your homework, you will have problems that you have to do with a calculator. That's fine. We'll talk about a couple of those examples. I will tell you the ones that I'm okay with using calculators on, and the ones that I'm not. Your answers must be in the form that I ask for. So if it's one that you're not supposed to use a calculator for the most part I can tell because the answers will be in decimals, and I don't want decimals. So let's look at this sine function for a moment. If you'll notice the graph here, it's taken a very specific portion of the sine function. This actually right there, the graph that I drew, is not a sine function, that's a cosine function. So let's look really quick at a sine function. It waves like this, okay? So it's going to take this very specific portion right here, okay, between negative pi over 2 and pi over 2. And that's where we're able to find unique values for the inverse. So we can do it very easily without calculators, all right? So this is the portion that we're going to be looking at. So be aware of that as you're going through this. We're going from negative pi over 2 to pi over 2 because everything is unique from that moment. It's one cycle where nothing repeats. All right. Now, technically, yes, we could go from 0 to pi, but that's not what we're going to do. We're going to go from negative pi over 2 to pi over 2. All right. So let's look at what an inverse sine function is. Okay. So it says for each value v, with v between negative 1 and 1, sine of the inverse of that value is a unique number in the interval negative pi over 2 to pi over 2, whose sine is v, okay? It sounds way complicated. I promise once we get to the examples, it won't be that complicated. Make sure that v is between negative 1 and 1. If it is not, you need to use a calculator. You can still do it, but you need to use a calculator. So, so let's go ahead and do some examples. So let's look, first of all, at this one. So it's a sine of negative 1, inverse of sine of 1/2. So what that means is that there is a value, okay, u, that equals 1/2. What is that value? All right, now that value has to be between negative pi over 2 and pi over 2. So I'm going to use my triangles. Okay, you're going to use a lot of these today. The problem is there's a lot of different ways that you can do these, and I'm going to show you a couple of different ways. You need to use the things that we've learned in trig so far for this. There's a lot of application of the things that we've already done. So this triangle is pi over 3, pi over 6, and okay, that's a right angle. 2, 1, root 3. Okay, you should know this triangle by now. All right, so which one will give me a sine equal to 1/2? So sine is opposite over adjacent. So u is equal to pi over 6. All right, so that one was very easy. Now it becomes a little more difficult when we're dealing with negative values. All right, so we're going to use our unit circle here. So what we're going to do here is we're going to look at this, the idea of sine of u equals negative root 2 over 2. So I want you to think about that on the graph for a moment. Okay, when we do the inverse function, it's going to go something like this. Oh, and where's not aligned? Okay, so if we're looking for the root 2 over 2, it's going to negative root 2 over 2. It's going to be somewhere down here. Obviously, it's not going to be up here because it's not going to be up here because it's not it's not a positive value, it's a negative value. So we just need to think about when we're looking at this, what value that could possibly be. So let's do our triangle first though. With root 2 over 2, I don't even necessarily need to do the triangle. U is going to be a pi over 4 value. But pi over 4 is positive over here, so it's going to be negative over here. So this is going to be a negative pi over 4. U is the x line, right? So that's that. I apologize for my board not being aligned. Alright, so one thing we need to be aware of is that the notation sine negative 1x is not exponential notation, okay? This does not mean that the sine of x to negative 1 or the 1 over sine x, okay? That is not the same thing, okay? An inverse function is different than an exponential notation. Please make sure that you're not using this as exponential notation. So, alright, cosine function, again, real similar idea, okay? We take the inverse of it. V again has to be between negative 1 and 1. And now the interval for the cosine function is going to be a little different. It's going to be from 0 pi instead of negative pi over 2 to pi over 2. So, all right, so let's find the following values. All right, so the first one says the cosine of the inverse cosine of 1/2. So we have the cosine of u equals 1/2. All right, triangle again. Okay. Some of you, I would hope most of you know this without, but I'm going to keep it up just in case. Okay. Pi over 4, 1 is easy. So we want to know what cosine of what is positive 1/2. So we look at this and we say, well, cosine is adjacent over hypotenuse. So the cosine is pi over 3. So u is pi over 3. All right. Cosine of what is 0. So, 0 is 0. Now, if you remember correctly, now this one you may have to think about unit circle, okay? Where is the cosine? 0. Cosine is 0 up here. Okay, so it's 0 at pi over 2. All right, now this one is a calculator problem. Honestly, you have the functions on your calculator. Put in your calculator. Cosine negative 1 of negative 0.63. And if you put that in your calculator, make sure it's in radian mode. If you have it in degree mode, it's going to mess up. Okay, I did that earlier today when I was trying to look at some examples. So it's 2.2523. Calculator problem. Seriously, just put it in there and we'll give you answers. All right, next example. All right, tangent. Okay, tangent is an interesting function. So tangent, the domain of tangent is all real numbers. You don't have to worry about restricting your domain of tangent functions. But the range is from negative pi over 2 to pi over 2. So you can't have anything less than or greater than that. So, so this is the rule. Let's go ahead and do some examples. Okay. Again, remember that that does not mean it's not an inverse, it's not an exponential inverse. So tangent, the first one is the tangent of u equals 1, right? What is that? So, and again, this is a, the triangle, this is the pi over 4 triangle. So u is pi over 4, that's a fairly easy one. The next one, though, is the tangent negative 136. Okay, this is a calculator problem. Obviously, you can't do this one on your own. So I put that in my calculator, and I end up with 1.5634. And that's it. And I believe that is all of our notes. That's all I have. Make sure that there's no more. That's it. Okay.